Oh, I forgot to mention one thing. A lane changing model is always coupled with the car following model. So when someone has already developed a car following model, you probably will also find a lane changing model in it. So in MSUM, we use Gibbs car following model. So the lane changing model is also belonging to Gibbs. And in VSEM, we use Wiedemann model, and the lane changing models are also belonging to Wiedemann. Understand this? In VSEM, we have, strictly speaking, we have two models. One for free lane selection, the other one for left side rule. In the free lane selection model, the vehicles are allowed to overtake in any lane. So the vehicles on the fast lane may overtake by using the slow lane. The vehicles on the slow lane can also overtake using the fast lane. So all the lanes are symmetric. They are all identical. But a more realistic case is called the right side rule or left side rule. If you are driving on the right side, it's right side rule. Using the right side rule, the left side and the right side are distinguished. What does this mean? The original idea is the vehicle on the right lane will switch to the fast lane to overtake. And it will switch back when it realizes that it's traveling too fast. So that distinguishes the right side and the left side. Right side is only for the slow vehicles, and left side is for fast vehicles. In this case, the overtaking in the fast lane will only happen if the speed is bigger than a threshold. So you are traveling larger than 60 kilometers per hour, then you can use the slow lane to overtake. But there is another thing called undertaking, which means the vehicles will bear the speed difference, will slow down, will bear it in the slow lane. So if the vehicle's maximum speed difference, the speed difference less than 20 kilometers per hour, then the slow traveling vehicle will not overtake. So it's called undertake. If the speed difference is not too big, the vehicles will stay in the slow lane. They will not overtake. So these are the two models. But we have a keyword which we can manually code in the VSEM's IMP file. It's network, how do I call it? Source file, not source file. In VSEM's model is all comprised in one file called IMP, model.imp. You can manually put this keyword in the file to specify a cooperative lane changing. This is not found in the manual or in the dialog. So you have to put it in the text file, IMP file. Remember this. If you specify this keyword, you please check the manual for how to use it. If you specify this keyword, then when the vehicles are changing lanes, they will be cooperative. Which means the lagged vehicle will slow down or even change to other lane to let the vehicle change lane. So the lagged vehicle will be more intelligent if you specify the cooperative keyword. Last time I talked about the driving behavior parameter sets, and I checked this tab called following. Now, if you go to another tab called lane change, you will be able to select the general behavior if it's for right side rule or free lane selection. And here are a lot of parameters. Now, let me talk about these parameters first. This parameter is called waiting time before diffusion. It's 60 seconds. This simply means if your vehicle has been waiting for a gap for 60 seconds, and you cannot still not make the lane change, it will be removed from the network. So you only have 60 seconds to find the gap. If you cannot do it, it will be removed, which is very cruel. The second parameter is called minimum headway. This headway, this default value is 0.5 meters. This means when the vehicles are stationary, they are standstill. If the vehicle, if you have a gap or headway to the lead vehicle of 0.5 meter, then you can make the lane change. This means the minimum headway you need to make a lane change when the vehicles are standstill. The third one is called too slow lane if collision time above something. This means if you cannot avoid collision in the fast lane, then, for example, if in the next second you are going to have a collision, then you go to the slow lane. By default is 0, which is no use. But if you specify this, then the vehicles will move more intelligently. They will avoid collision. They will make the lane change to avoid collision. And this is a safety distance reduction factor. In lane change, in the lane changing, the distances between vehicles are going to be affected. When VSIM is modeling the car following, each vehicle has its own safety distance. But this can be reduced by this factor for in lane changing. So the vehicles can change their lanes easily. And this means it only needs 60% of the original safety distance to make the lane change. The next one is called maximum deceleration for cooperative braking. So if the vehicles are cooperative, then the lag vehicle will have a maximum deceleration. They will try to decelerate to make the gap. And the last one is called overtake reduced speed areas. In VSIM, if you remember, we have some areas called reduced speed area. And if you allow the vehicles to overtake in these areas, check this box. Alright? Now let's talk about these parameters. They are called necessary lane change. Actually, it is the mandatory lane change. In VSIM, it's called necessary lane change. We can define the maximum deceleration for two vehicles. The first vehicle is the own vehicle, is the own. The second vehicle is the trailing vehicle or the lag vehicle. For making a lane change, they have to decelerate. And these are the parameters in VSIM to control the maximum deceleration. This figure is probably easier. So you want to specify, this is emergency stop or the intersection. Let's think about this as an intersection. At the intersection, you can use the maximum deceleration. This is first parameter to specify. Then if it's far away, then you use another maximum deceleration. Here, it can be specified. Then another thing is the slope of this curve. So in VSIM, when it's very far away from the intersection, you have a small maximum deceleration. And here, when you are approaching the intersection, you are going to get a bigger maximum deceleration. And these are for both vehicles, the own vehicle and the lag vehicle or the trailing vehicle. Two curves. So these 6 parameters, 6 numbers are defining these two curves. Alright? Now I have already finished talking about VSIM so quickly. I want to mention another thing which is not related, not directly called lane changing, but it's useful, it's very unique in VSIM. It's called lateral behavior. Lateral behavior means in VSIM, a lane has its width, and by default, the vehicle will travel at the center of the lane. But the lateral position can be changing. And let's suppose we have a lane that's wide enough that can hold 2 vehicles. Then probably, if the gap is big enough, then the vehicle can pass the vehicle in the same lane without changing to another lane. So if you are modeling a bicycle lane, you have a wide lane and you have several bicycles, and bicycles have very small width. Then the bicycles can pass each other in VSIM. This is called the lateral behavior. These are parameters you can define. You can define where the vehicles stay at when it's free flow. you can define the minimum lateral distance when the vehicles want to pass. All right. So this is very useful for modeling bicycles, or even bicycles with, or motorcycles with cars. So they can pass without using an additional lane. All right. I have finished talking Visim, IMSUM and Visim. Now I want to talk about COSIM. For COSIM, I picked FreeSim, which is the freeway model, as an example. And I only want to talk about the discretional lane changing, which is more complex. It has two parts. The first part is the necessary conditions for lane changing. So if a vehicle cannot hold a suitable headway space, the suitable headway space is defined in the car following model. If this cannot be held, and the current speed is less than the free flow speed, then the vehicle has the potential to make a lane change. So the headway is not enough, and the speed is less than the free flow speed, then I probably will make a lane change. However, the critical factors, there are two critical factors that will be calculated. The first one is called the lead factor, which describes the disadvantage of staying in the current lane. It will be calculated using like a curve, like fuzzy logic. So when the headway is very small, the advantage will be 1, the disadvantage will be 0. When the headway is very big, the disadvantage will be 1.